So now what we're going to look at is we're going to look at writing a compound inequality for each graph. And if we start out with a graph, we actually don't have to solve the algebraic inequality. All we really need to do is really understand what this graph represents. So the first thing we're going to do is just write down our boundary numbers. And so we write down -3 and 2. Then what we have to do is recognize what the open and closed circle mean. Please notice for this, even though it's a compound inequality, they do not have to be the same. Okay, the inequality sign doesn't have to be the same. And how do we know that? We know that because this is the one for the -3 is an open circle. And so that would mean that everything we're talking about in this graph is greater than -3, but not equal to, because it's an open circle. That would be our electric fence. Everything we're talking about in this graph, on the other side, the right side, since there's a closed circle, it's kind of like just a regular fence, must be less than or equal to 2. And since we're looking at the bar on the inside, this bar on the inside represents all of my values. Any value I want for these numbers. And so any value that I want for these numbers, I'm going to represent by a variable. The variable representing any of the numbers that fall between my two boundary numbers. And since that variable sits in between these two numbers, because all the numbers that make this inequality true sits in between these numbers, I put my variable there. And what I've actually done is I've written down the answer for this inequality. I could put it in set notation, since I decided to use x such that this happens, fancy bracket on the other side. And now I'm completely finished writing this in set notation, but also recognizing that if I were to graph what I'm looking at, I should end up back where I started. I have an open circle on my boundary number of -3. I have a closed circle on my boundary number of 2. The numbers that we're talking about sit in between those two numbers. Therefore, my variable, which represents all of the numbers in between there, sits in between it. The next thing we're going to look at is this graph. And again, we start with the graph, so we're going backwards in this case. We're not starting with the algebraic inequality. We're starting with the graph of the compound inequality. So what we're going to do again is write down our boundary numbers. Nothing has changed in that respect. And we're going to now notice that there's not one part to this graph that's shared by these two. There's two parts to this graph. There's really a left part and a right part. And if we remember, our compound inequalities are really two simple statements combined by either an AND statement or an OR statement. Well, if we look back, this would be an AND problem. The variable sits in between, and we're talking about where do these two pieces of information intersect in between. This, however, would be an OR problem. You're either less than 3, which is what this arrow pointing to the left means, or you are bigger than 6. And that, remember, for all OR problems, we need to actually write down the word OR. So since this is a compound inequality, I'm going to use the same variable for both sides of it. And I'm going to basically put that variable whichever way the arrow is going. Okay? Now in this case, what we're saying on the left side, okay, for our left side, we're saying this, that x is actually less than or equal to, because it's a closed circle, 3. On this side, however, we're saying that 6 is less than or equal to the x that we're talking about, because x is greater than or equal to 6, again, because of the closed circle, the or equal to part. When we actually look at this, we finish writing our answer. If I do it in set notation, x such that x is less than 3, or, because you can't be both, greater than or equal to, less than or equal to 3, I apologize, or greater than or equal to 6. Another way of saying that is 6 is less than or equal to x. Thank you, and I'll see you guys tomorrow.